we have something a little bit different on the bench today, including some parts from another project that's in progress. But I purchased this pack of radio, charger, power supply. It did come with a battery. It didn't, however, come with an antenna, which I purchased separately. And I also purchased an additional battery because I suspected this battery was going to be pretty dead, as it's, let's see, dated 2011, 24th of June 2011. So I don't hold much hope out for that battery. So I purchased a new battery for the radio as well. And when it came to test the radio, everything was dead, totally dead. I managed to power the radio separately off the two contacts here on the back of the radio that would normally contact the battery, and this requires around it says 7.2 volts or thereabouts. This is a nickel cadmium battery that is the original battery, and of 1500 milliampere hour. So the battery I purchased to replace it is actually a nickel metal hydride 7.2 2200 milliampere hour battery. So it's a better battery, and it should last a while. So anyway, I came to check it, and I bought the programming cable for the radio because it can't be manually programmed very easily, because all you've got is the PTT. You've got a couple of buttons here, this orange button, a couple of buttons here, and the rotary control on the top. So, oh, and there's toggle switch. So there isn't really much in terms of the way to program the radio. So you program it normally with a computer through a USB cable that connects onto this interface here. So I was able to test the radio, program the radio, get the radio working. Had the antenna for it, so I could check that it transmitted and so on. However, when I come to charge batteries, I found that the charger doesn't do anything. So there appears to be a problem with the charger, and I wouldn't think there's too much involved in the charger, but who knows. Normally chargers are fairly straightforward, fairly simple. So the first thing I'm going to do obviously is check this power supply, make sure the power supply is functioning properly, and then we'll go from there. Okay, so let's plug the power supply in, make sure we're getting some output from the power supply. That's always the first thing to do, check your power supply. So let's see what we have from the power supply. And checking the power supply, we have 18 volts DC, and it's supposed to be a 15 volt DC power supply, but it's not loaded right now, and it's 15 volts at 1 amp, and unloaded we're getting 18 volts. So power supply is okay. So it's going to be a little more complicated than just replacing the power supply. Bit of fluff appeared from somewhere. Okay, so not going to worry about the radio right now because I know the radio's working. So this is the next thing to suspect. So if I plug the power into it, we're supposed to have a red or a green light. So a red light when it's charged, when the battery's charging, and a green light when it's complete. And I'm going to plug the new battery in for test purposes. We get nothing. We get no lights whatsoever. And if I check the outputs on the terminals here, we've got negative here on the left. We've got nothing, nothing, nothing. So we get 0 output from the charger. So I guess we're going to pull that apart and see what's going on. Oh wow, it's a lot more sophisticated than I imagined. It looks like there's a number of ICs in this charger, far more sophisticated than I thought it might be. So it might be a little more difficult to fix because I don't have the service manual or schematic diagram for this charger. I didn't look online because I didn't think it was going to be very complicated, but I might need to go online and find the schematic for it to do a bit of fault finding. Okay, well, we've got it out of its plastic housing, and yeah, there's several ICs. This bigger one down here, AS-222C. Then we've got a JRC, looks like R0500, and this NEC Micro PC 494C. Okay, well, a lot more complicated than I suspected it was, but we've got a few things that are obvious we can check. There's fuse here, a PCB mounted fuse, there's some diodes, a lot of semiconductors. Looks like some sort of bypass component, possibly a regulator of some kind. This could be another, this looks like another fuse mount, or maybe it's a thermal fuse mounted to this heatsink here. There's the LED, which is easy enough to test with a meter, and so on. So yeah, there's plenty of diodes and other components on here that we can test. This looks like some sort of crystal, maybe. It's got 4 printed on it, so I don't know whether that's a 4 meg resonator of some kind, maybe. Don't know. Maybe this device or one of these devices needs a clock circuit. I don't know. So anyway, let's do some more testing. This time I won't need to power it, so we can leave the power off. We can leave the power off for the time being, and I'll just use continuity or diode mode to do some tests. So what have we got? Well, I'm going to go on diode test. I think that's a good place to start, because we've got a diode here which reads okay. What else we got? We got a diode underneath here, which I can't quite get at properly. That looks all right. Another one here. Looks all right. And there's one down here. Looks like there's a capacitor across it charging. I guess that's all right. Yeah. We've got the LED itself. See what we get from the LED. I think it's a center common. It's a dual color LED. Let's see what we got. Oh yeah, that's red. And this should be green. I don't know whether you can see that, because I can hardly see it in this light. But it's center. Yeah, that's green. Gone the other way. We should have it show up in red. Yeah, just about to see it glowing red. So the LED's okay. Well, I was pretty sure the LED was okay because there was nothing coming out of the terminals, and I would have expected to see something on these terminals, but we're getting nothing. I don't see any damage to the board itself. No obvious damage anyway. I don't see any burned components, and I don't see any charring of the printed circuit board. So it looks like we might have to get a bit technical on this. I think what I'm going to do is now I'm going to put some power into the board and see what I can measure on the board itself. So I've put the 15-volt power supply into the unit now, and I'm going to make some measurements on the board, see what we've got. So we've got 15 volts coming in, or thereabouts. Yeah, there's our 18 volts. There's the negative side, here's the positive side down here. And the first thing that's going to go through is this fuse. So let's check the fuse. Yeah, it's going to the fuse. And it goes to, oh, that diode. Okay. So let's see. It goes to the fuse and goes to the diode. Then comes down here. And we've got a capacitor to give some filtering down here. And it makes the capacitor and then comes down here. And it looks like it jumps across to here. Yeah. Oh, it's a link. Okay. Well, it jumps across from here to here. And that's getting there fine. So it looks like it gets to this bypass component. Sorry, this pass component, this pass semiconductor. It looks like it gets to here fine, so yeah, it's feeding this pass component, which will eventually, I guess, will eventually go back and link up with the output, which looks like it should be over here. Now I've got 18. Now I'm reading 18 volts on one of these terminals, the main terminals. That's between the ground or negative input and one of these terminals. Now is showing 18 volts. Or thereabouts. So if we get 18 volts on the output, are we not getting 18 volts? Are we not getting a negative supply? Because the positive side is reaching the terminals. We didn't have that before, so it looks like the negative side, which I assume is over here, this, yeah, this is the negative side is here, and we're not getting 18 volts, but we are if we measure it from here, which is pretty weird. Now obviously there's got to be some control with this pass component to limit the current, because it's a constant current charger. So what are we missing? We're missing the ground leg, which looks like, let's see, well, the negative, let's follow the negative path. We said we got it negative here, we've got negative here on that capacitor. We got negative here, which looks like it's part of the heat sink, and ground of the unit. And then let's see, it goes off down here, here, and then up to here. Oh, wait a minute, we don't have it here. Well, that's weird, because I had it here a minute ago. Ah, I think I've found the problem. We must have a break. We must have a break on the board, because I've got the 18 volts from here to here, sorry, from the input here all the way around, all the way around the board. Looks sort of weird, but I've got 18 volts here, and then it stops, so it's got to be a break, and I assume the break's right here, because yeah, we got a break on the board. I don't see the break, but the break, I can point to it. The break is right here between this ground and this printed part, the printed circuit board. There's no continuity. So it must be broken right across here. But like I say, I cannot see a break. This here looks a little dodgy. Maybe what... I wonder if this got dropped or pushed around or something. It's weird because I don't really see... There's no crack in the board that I'm seeing. But the break must be from here to here. Oh well. Hopefully that's all that's wrong with it. That was easier than I thought. I might clean some of this off too, and just resolder this. But it's not. The brake isn't here. The brake is here, or somewhere close by. We check continuity from here to here and see what I get. Yeah, nothing. So the brake is right across. Wow, that's weird. The brake is right at the edge here of the mount for this heatsink, where this mounts the printed circuit board, and the crack must be just there, just across there. Huh. Strange. Well, anyway, I'm going to clean that up, put a bit of wire across there, and see if that cures the problem. So let's see. Scrape some of the printed circuit board away. Not the printed circuit board, but the etch resist. Get my iron warmed up. See, I might just solder up to here. Just twisting the end of that wire before I solder it to the board there. Okay, well, let's bridge that break. A piece of wire. So hopefully, let's check it again for continuity. So we're from all the way over here. Oh, that's better. Yeah, we've got continuity all the way around to here now. So we've got a ground. Odd. Very odd. But anyway, we appear to have success. Let's put the soldering out of the way for now. And what I'm going to do is do a few more checks here before I reassemble it. I can never understand why people on YouTube, when they're repairing things, reassemble everything completely to find that they still have a problem. I don't understand. I mean, why not just check it before you reassemble it totally? It doesn't make any sense if people just reassemble everything, put it all back together, put all the screws in, and find it still doesn't work because they didn't find the fault. But anyway, let's see what we got now. Let's bring this into view. Hopefully you can see the meter. And what have we got? Well, this is the ground. Yeah, we've got 14 volts. 14 volts and ground. So we've got 14 volts coming out, and we've got negative here. So negative here, positive here. All right, we've got 14 volts and 14 volts. This one's the temp sensor terminal, so I wouldn't expect to see much on there. But the two positive terminals are working fine. We've got 14 volts on both of those. So, looks like it's fixed. But we'll get it all back together. Well, actually, could I check? I might be able to check by just putting the battery against the contacts. Oh yeah, we got an LED come on. We got a red LED. It's a little fiddly to hold the battery in place, but there we go. One red LED. I wasn't expecting it to be green because this battery won't be fully charged, but if we place the battery up against the terminals, we have a red. Let's show you that. Place the battery up against the terminals here. We get a red LED. Hopefully you can see that. So yeah, looks like it's working. That's good. So yeah, I'll power it down and reassemble it. Give it another test. We should be good to go. How easy this is going to be to get everything just in the right spot, but shouldn't be too difficult. Might have to push those contacts back a little bit to get the thing to line up properly. Why is it not lining up? Should go straight down. Oh, there we go. I think it just... No, that's not right. The contact's not in the right place. That's better. That's perfect. That's back together now. Well, it will be once I get the back and the screws in. Okay, so let's put it back in again. Put some power to it. Okay, so let's see what we've got now. It doesn't matter where you put your leads, they always get tangled up with something. Okay. $14. Yep, 14 volts. 14 volts. Great. So let's put this in. Red light. You see that? I don't really see that with all these lights, but we're getting a red light, so we're showing it's charging now. Which we weren't getting before. So that's great. Now, this battery is the old dead battery, and this one is the new battery. and that's also charging, which I would expect. I'll put the light back on. So yeah, so great. Let's see what the new battery is showing here. 8 volts, so that's pretty when it's charging slowly, which I would expect. 8.077, 8, 9, 8.8, and it's still charging. Cool. Great. Now let's see what the other one does. If it does anything. If it does anything at all. Yeah, that's not very hopeful. I mean, it's gone up to 9 volts, which tells me it's not actually taking a charge. If I leave it on there long enough, I guess it might provide a charge, but going straight up to 9 volts from about 2 volts doesn't give me a lot of hope. Which, you know, I was pretty sure the battery was dead anyway, so see what it measures now. Well, it measures 8 volts, but that's dropping rapidly. So anyway, looks good. So let's put this back onto the radio. Go back on. And I have this program to give me the weather channel, but I don't know whether I'll pick it up in this in here, because it's yeah, nothing. It's this building is screened. It's like a Faraday cage, literally. So let me kill the squelch. Yeah, I can just about hear it coming through, but I mean, that's, you know, that's expected because the screening in this inside here. So great, let's plug that into the charger, and it's charging, and I would say we have a fixed charger. By the way, this is a Kenwood TK-290 without the touchpad on the front. It's just got the display on the top with the regular buttons, and the charger is the KSC-20 rapid charger. And well, this battery, let's pop this battery off again. This battery is the KNB-17H. And the original battery is the EPK NB17A 7.2 1500 mAh battery, NiCad. So just for clarification as to what we were just looking at, and I'm going to put the new battery back on for now. and put that in the charger, and we're good to go. So if you liked the video, give me a thumbs up and subscribe for more videos. Thanks for watching. Bye for now.